continuous flow, guys, there is difference between incompressible fluids. Incompressible fluids, that means uh, yung fluid na yan are liquids. So to get the relationship between the incompressible fluids from point 1 to point 2, ang gagamitin natin na formula is yung discharge A1 equal to V1 equal to A2 V2. Pag gas naman yung sinosolve natin, which is a compressible fluid yung gas, ang gagamitin natin sa relationship between the area and velocity and tsaka yung density niya is itong density 1, area 1, V1 equal to the density 2, area 2, and velocity 2. So yun yung pagkakaibahan ng liquid tsaka gas. Gagamitin mo yung discharge pag liquid, gagamitin mo yung mass flow rate pag gas. Next is we discuss also the the Reynolds number. So the formula for Reynolds number is velocity times diameter times the I over the kinematic viscosity. If ang given sa problem is kinematic viscosity. And since kinematic viscosity is equal to dynamic viscosity over the density, ang pag-given naman sa problem dynamic viscosity, ito yung magiging formula. Density times velocity times diameter over the dynamic viscosity. So, ano yung purpose ng Reynolds number? Ang purpose ng Reynolds number is maalam natin kung ang flow is laminar or turbulent. Pag laminar, that is less than 2,100. Pag turbulent naman, greater than 2,100 yung value. So, we also have energy and head. So, ang energy is composed of three. We have the kinetic head, the elevation head, and the pressure head. So pag perfect yung energy flow, which is E1 equal to E2, walang friction, wala ding machine, then we could say that that is a Bernoulli's energy theorem. So that is a perfect flow or perfect energy flow. So we discussed this also. Again, we introduced pumps and turbine, which is one of our machines, yung machines na idadagdag natin. So, yun. Also, since we are talking about machine, meron din yung power na kaakibat. How do we find power sa machine natin? Power is equal to the Q, which is discharge or volume flow rate, times the density, the specific weight of water flowing on the system, times H. Ano nga tong H? It is the energy head. So, it depends upon kung ano yung ginagamit na machine or equipment. Ang H na to, it's either head turbine or head pump. Magdedepende yun sa system ulit kung turbine at saka pump kung ano tong H na to, H in or H out. To find the H in and H out, kailangan natin ng P in and P out. But usually ang given lang kasi is isa lang dito sa P out or P in. So in order to find which one of these kailangan natin yung efficiency. So, i-given yung efficiency where yung efficiency is equal to the power out over the power in. So makukuha natin ang isa sa mga to. So familiarize also the common conversion ng power. Okay, so I have also discussed this to you, yung flow ng system kung turbine tsaka pump. Pag turbine, automatic yan ha, yung turbine, ang HT dito, which is the head turbine, is the HT in. Bakit naging HT in nga to? Because ang system or yung itong flow na to, yung napaloob sa system is yung H in. Kasi ang turbine, gagamitin yung energy sa fluid para i-convert niya to electricity, para magkaroon tayo ng electricity. Kaya automatic, ang turbine is negative HT in. Okay, if you consider friction, of course, isa-subtract natin sa formula yung friction. Next is yung pump naman. Pag pump, pag pump naman, ang use ng pump is gagamitin ang electricity outside to push the fluid from the lower point to the upper point. And since napaloob sa system itong flow, napaloob tong PHP out or P out, automatic, yung ating formula is positive HP out. So, masosolve natin una is P out. Okay? So, of course, if we considered friction minus friction equal to the energy 2. So, another term for P in is power supplied. Another term for power out is power generated or PO. Malalaman natin ang isa sa mga to with the use of our formula efficiency equal to PO over P in. So, yun yung doon tayo tapos nag-example tayo, 'di ba? Last time. Okay, do you still see my screen? Okay. So again, there are conditions of fluid flows. Yung fluid flow na perfect, which is E1 equal to E2 lang. So, substitute lang yung value ng velocity over 2G plus Z plus P over the specific weight. This is the kinetic head. This is the elevation head. This is the pressure head. Kung lalagyan natin ng friction with head loss, kasi yung friction is head loss is caused by major friction. So, isa-subtract natin yung head loss. Okay? Usually given yan, but meron tayong mga formulas dito later on. If we add a turbine sa system, subtract HT, ano nga to? HT in. If we add pump to the system, we add pump. This is HP out. Okay? If we add turbine and we consider head loss, of course, minus HT in minus head loss. Last case, if we add pump and then we considered head loss, that is additional HP out minus HL or head loss equal to the E2. So these are the cases of our problem na solve. One, there is a 14 kilopascal pressure. The elevation head at point 1 is 2.5, sabi niya dito, from the datum. And yung diameter ng pipe sa point 1 is 600. Ko-convert ko lang to radius in meters, 0.3. Sa point 2 naman, paglabas ng water, since this is water, ang pressure niya magkakaroon lang ng 4 kilopascal. And of course, from the datum, point 2 is 0. And yung kanyang diameter is lumaki. Hindi lang siya obvious dito, but lumaki yung diameter niya, which is 900 mm. Convert ko to radius, magiging 0.40 meters. So, ang formula dyan, since we're not considering friction kasi hindi binanggit yung head loss, ano yung formula yan? That is E1 minus HT equal to E2. So, this is head turbine, right? Turbine. So, this is turbine. So, yun yung HT in. Okay, this is HT in. So, E1 is composed of these energies minus HT in and then energy for HT2. As you can see, ang wala lang dito is yung velocities. So, we need to find first the velocities. Velocity from our formula dun sa ating discharge, U1 equal to A1. Convert ko lang yung 500 liters per second. And yung discharge natin is equal from 0.1 to 0.2 since this is a series or continuous flow. So, equal lang yung Q1 and Q2. Makukuha mo yung velocity 1 and velocity 2. Next, if we try to analyze, again sa system na paloob yung HT in. So, meaning, ang masosolve natin dito is HT in. So, if you substitute velocities dyan, and yung mga values natin, makukuha natin yung HT in. Ang hinahanap pala dito is yung compute the horsepower, power supplied. Okay. So, since this is HT in, makukuha natin yung power supplied or power in. This is power supplied ha, P in. So, that is Q, specific weight of water since we are talking about water, times the head turbine in. So, ito yung nakuha natin sa in. Dapat consistent yan. Pag in to, then in din to. Pag out yan, then out din yung sinusolve mo. So, convert lang to HP kasi hahanapin pa natin yung efficiency. Okay. And binigyan tayo ng 19 horsepower converted to electricity. Itong 19 horsepower, ito yung P out. Ito yung kinonvert na electricity. Since meron na tayong P in, makukuha natin yung P out, ay yung efficiency. So that is P out over P in. So P out is 19 horsepower over 24 horsepower, or you can use 23.99989. Do not sa round it off until hindi pa tayo nag final answer. So ang efficiency natin is 79.167. Next, na-discuss din natin to last time, which is ito yung illustration. Hahanapin natin yung height from B to C. So as you can see, ang given lang dito is velocity at C. Wala tayong velocity at A. And alam natin yung ang discharge QA, QB, and QC is equal since this is continuous flow and this is a series type. So to find QC, since meron tayong VC, makukuha natin yung QC, which is this one. And QC and QA, QB is equal. Makukuha na natin yung VA. Okay? So, which is QA over AA. Area at A. So the formula here is AA, or energy at point A to energy at point C. Since we're using pump, this is HP out plus HP out. Okay? Minus HL. Since meron tayong kinoconsider na head loss. Kaya merong head loss. So, substitute the energies. Ang makukuha natin is yung kukunin muna natin mismo yung dito, HP. And since ito yung analysis ng kanyang energy flow, so ang napaloob dito is P out. Of course, ang HP dito is HP out since the system considers the fluid flow. So, given tong P in, which is 24 horsepower suction pump, ito yung dito, and also the efficiency na 70%, makukuha natin yung power out. This is power generated. So, convert ko lang to kilowatts. And since meron na tayong power out, makukuha na natin yung HP out. Which is isa-substitute natin dito since ito ang HP out. Okay? So, ang HP out is equal to P out over Q times specific weight from this original formula. So, i-substitute natin yung HP out. So, makukuha na natin yung value ng H. VA, ang ZA is 0 from the datum. Ang ZC is 1.8 plus H. So, ang hinahanap natin dito is H. So, as you can see, ang H na lang dito yung variable na makikita. Ito yung hinahanap. Again, ang additional information lang dito, pag sinasabing pag sinasabing atmospheric pressure yung pressure, magiging 0 yung gauge pressure natin. Which is, ito yung case ng point C. And pag sinasabing suction pressure, or ano ba to? Suction pressure meaning negative yung ating gauge pressure. Kaya negative yung pressures at point A. And 0 yung PC. So let's continue. So, a maximum rate power generation, a small hydroelectric power plant takes a discharge of 14.1 meter cube per second. An elevation drop of 61 meters. The head loss is 1.5. So, wait. Hindi lang ulit nagana. Teka lang. Teka lang ha. Ayusin ko muna yung PowerPoint. Part. Okay. Kita niyo yung screen. Hello, kita niyo yung screen? Okay, so let's draw first yung illustration dito. So it says here that a maximum rate, so there is a waterfall that converts energy from turbine to electricity. Okay, ito yung ibig sabihin ng problem na to. So ang turbine ay ang energy ng waterfall, i-convert ng turbine into electricity. And the elevation of that lower head, upper head to the lower head is 61 meters. So that is our reference point. Ito yung below. And additional information, if we say reservoir guys, so this is reservoir, open space or open large bodies of water, yung ating source ng energy flow, ang ating velocity dyan magiging 0 at point 1 at ang point 2, 0 din. Ang pressure naman dito is 0 and pressure dito is 0. Because ang explanation dyan guys, example, pag malaki tong bodies of water, okay, imagine this is a lake, okay? Pag nababawasan tong tubig na to, dadaloy dito, ang lake na to is hindi magkakaroon ng change ng velocity. Because magdadagdag pa ulit yan ng tubig. Or there is a minimal change of velocity because, yun nga, meron pang source dito na magdadagdag. And maliit lang yung energy niya. And of course, the area, as you can see, the formula, okay. If we analyze this one, bakit naging zero tong velocity pag reservoir or open space or open bodies of water yung source? Nagiging zero to siya pag malaki yung area. Okay? Hindi katulad ng sinosolve natin kanina ng area dito is yung pipe, area ng pipe. As you can see, ang area lang ng pipe is ganyan, right? Maliit lang. Pag yung area na sinasabi natin is bodies of water, mas malaki yan, di ba? Yung bodies of water. So, habang lumalaki tong area na to, the value of our velocity is liliit, is lesser. So it is considered that the velocity at an open, wide, or bodies of water will become zero. Okay? So area is inversely proportional to the value of the velocity. Kaya yung velocity pag ang bodies of water yung source ng energy flow magiging zero. Yun yung explanation niya. Next is yung pressure natin is zero because it is open at the atmosphere. Di ba sinabi na dun sa ating last problem, pag ang binabanggit is atmospheric pressure, magiging zero yung ating pressure dito. Since open siya, so yung pressure niya is zero. So yun yung additional information. Pag ganito yung problem, reservoir, automatic, yung velocity at point 1 and point 2 is zero. Of course, also the pressure and pressure 2 is zero. That is the explanation. Okay, ano pa yung given natin dito, which is Q. Q there is 14.1 cubic meter per second. Again, Q1 and Q2 is equal since that is a continuous flow. Ano pa yung given dyan? Meron pa tayong Z, di ba? Yung Z dito is 0 since nasa reference point siya. Yung point 1 naman dito is 61 meters. So we are considering friction since may binigay na head loss. So the formula here is, and since we're using head turbine, that is E1 minus HT, ano nga to? HT in minus head loss equal to E2. So that is B1 squared over 2G plus Z1 plus P1 over the specific weight minus HT minus HL equal to V sub 2 squared over 2G plus Z sub 2 plus P2 over the specific weight. Again, kung magiging 0 to, 0 yan, 0 to, 0 to. Of course, because of that explanation kanina. So, ang Z1 na lang natin ay 61 meters. HT is hahanapin natin, HT in. Head loss is 1.5. Z2 is 0, right? So, HT in is equal to 59.5 meters. So, since we are solving HT in, ang makukuha natin is PT in or the power of the turbine in or the power supplied by the turbine. So, that is Q equal to HT in. P in is equal to, the Q is 14.1 times this is water, right? 9.81 kilonewton per cubic meter times the HT in 59.5 meters. So, ang power supplied ng hydroelectric power is 8,230.00995 kilowatts, or that is, sabi kasi niya in megawatts, so that is 8.230 megawatts. So again, this is what we call, ang PN is power supplied. But ang hinahanap niya is power generated. Ano nga yung power generated? That is the power out. So find power out, kailangan natin ng efficiency. Wherein given yung efficiency, which is 0.87, ito. So P out over P in, this is equal to 0.87 P out over 8.230 megawatts. So P out is equal to 7.160 megawatts. So that is what we call the power generated. Again, power generated is P out, power supplied is P in. Gets yon? Let's proceed to example number 2. 50 centimeter pipe diameter, the water rate of 0.5 cubic meter per second. A pump is used to move water from 30 to 40 meters. So the elevation at point 1 is 70, the pressure. Point 2 is 350. What power in horsepower generated by the pump? Ano nga yung power generated? Considering 86% of efficiency at the pump and 3 meter head loss. So ano yung hinahanap dito? Yung generated, that is na. What is that? Generated?
Power out po ba, sir?
Okay, very good. That is power out. So let's try to draw first the illustration. So it is a pump. A pump used to um, used to push water from lower point to upper point. And it says here that yung point 1 is 30 meters from our reference. And yung point 2 is 40 meters. Okay, so this is Z1, 30 meters. Z2, that is 40 meters. Ano pang given? At point 1, that is 70 kilopascal. Right? Point 2, that is 350 kilopascal. Tama ba? Ano pa yung given? The diameter at point 1 is, ano ba? Okay. Sinasabi dito, 50 centimeter pipe. And wala siyang sinabi na ang point 2 is nagbabago yung diameter. So meaning, point 1 and point 2 has the same diameter. Point 50 centimeter. Okay, so ano ba yung hinahanap dito? The point, okay, so let's try to write the formula. So since we are using pump and we are considering head loss, ang formula niya is E1 equal to plus HP minus HL equal to E2. So this is HP out since that is a pump. Okay. Okay, as you can see, yung value ng velocity dito sa velocity 1 is magkakapareho na. Tunay ba? May Q pa pala. Q is magkakapareho yung kanyang velocity if we try to solve that one. Since Q here is 0.5 cubic meter per second. Bakit magkakapareho? Because of the diameter. Okay? So pag magkapareho yan, di ba? That is 0.5. Same din yung QA. Q1. Area 1. So since area 1 and area 2 is equal, magkakapareho. So since same sila, where Q1 and area 1, so ay area 2. So velocity will be equal. Tama? So if you try to analyze this one, VI squared over 2G plus Z1 plus P1 over the specific weight plus HP out. Shit. Minus head loss equal to V2 over 2 squared plus Z sub 2 plus P2 over the specific weight. Yan. So, if you consider V1 and V2, if magkapareho sila, automatic, 0 na yan, di ba? Ba't magiging 0 yan? Pag i-transpose mo yan sa left side, if we subtract same number, same value, magiging 0. So, automatic 0 yan. Pag the same yung diameter, velocity is equal. Pag same yung velocities sa point 1 and point 2, magiging 0 yan. Gets yun? So, ang natitira na lang natin is Z1, which is 30. P1 is 70. That is water, di ba? 9.81 yung specific weight ng water. HP, ito yung hinahanap. That is HP out. HL is 3 meters. Z sub 2 is 40 meters. And lastly, the pressure at 350 over 9.81. So HP out here is 41.542 centimeter meters. Okay? So, makukuha na natin yung power out. So that is Q equal to the specific weight times the HP out. Since we're solving HP out, then makukuha na ulit natin yung HP out. P out. That is 0.5. The discharge times specific weight ng water, 9.81, times HP out na 41.542. So P out here is equal to 203.765 kilowatts. So ang sabi niya in horsepower, convert lang to horsepower. 1 horsepower. 273.143 horsepower. So you don't need na the efficiency. Okay, may mga problems na malilito kayo kasi binigay yung efficiency pero hindi naman kailangan sa problem. Since ang makukuha na natin dito is energy out, diretso makukuha na natin yung power out or power generated. So you don't need to have the efficiency. Kung kailangan natin ng efficiency, ang hinahanap kasi dito is power in or the power supplied. Okay, relationship between Q and head loss. So for series pipe guys, for series pipes, the head loss 1 and head loss 2 is equal. When you total the head losses, that is equal. Again, for series pipes, yung mga sinasolve natin are series pipes. The Q1 and Q2 is equal. For parallel pipes naman, hindi pa tayo nagsosolve ng parallel pipes. Q1 and Q2 plus Q3 is equal to the discharge total. Kabaliktaran siya, yung parallel pipes, the head losses at point 1 and point 2 and point 3 is equal. Okay, so kanina hindi natin diniscuss if ever wala yung head loss. Okay? So ang head loss, mayroon tayong formula. Ang formula niyan, originally this is F times length of the pipe times velocity squared over the diameter times 2 times the gravitational force. So, marami din tayong formula on how to find head losses. We have the Darcy-Weisbach, Chesney-Mannings, and Hazy-Williams. So, magdedepende yan sa problem. Pag binigay yung F, ang gagamitin na formula is Darcy. Pag binigay yung N, you use the Chesney-Mannings. Pag binigay yung letter C or the roughness coefficient, that is Hazen-Williams formula. So, meron siyang kaukulang SI unit, SI formula, and English formula. Okay? So, F, N, and C are pareho lang sila. That is roughness coefficient. So, magkakaiba lang yung formula nila dahil iba-iba silang proponents from different countries. So, ang formula na to has also an SI and English. Okay? Sa SI, ito yung SI na formula niya or metric, 0.086, 0.0826 friction times length of the pipe times discharge over the diameter. Meron dito siyang equivalent sa English. We will discuss it later on. Since ito yung pinaka common na formula for head losses. Since this is head loss in terms of Q. So, ang original formula niya, ito yung original, that is head loss in terms of velocity. Okay, so let's try to solve series type of problem. So, pag series, ano nga yun? The head loss at 1, the head loss at 2, then head loss of 3 is, ito total mo pa yan para makuha yung head losses. Okay? That is a series. But the Q1 is equal to Q2 and equal to Q3. So, the same lang yung value ng Q1, Q2, and Q3. So, again, ano yung pinaka-common na formula ng head loss? That is the Darcy-Weisbach. Ito yung formula na gagamitin natin since we are considering head loss in terms of discharge letter Q. So, ang original, you can use this one, head loss in terms of velocity. But ang given kasi natin is head loss and discharge. So, we can use this one. And since this is SI unit, so ito yung gagamitin natin. Teka lang, nag-ano na. So, sinulat na pala dyan. Okay. So, to find head loss 1, kailangan lang natin ng mga given at point 1. This is the length of point 1, diameter of point 1, and friction at point 1. Okay, this is the pipe 1. So, use the formula 0.0826 FLQ squared over D raised to 5. Substitute the given values. Kailangan lang siya nakameter, yung diameter, and nakameter lahat para magkaroon tayo ng consistent of conversion or cancellation of units. So, ganun din yung HL2, 0.0826 times friction at 0.2 times the length of 0.2 times the discharge of 0.2. Again, discharge from 0.2 and 0.2, 0.1, 0.2, and 0.3 is equal. So, this is the diameter of 0.2 in meters. So, this is the head loss at 0.3. This is friction at 0.3. Just follow this formula. Length of 0.3. This is the discharge of 0.3, which is equal. And of course, the diameter of 0.3 in meters. So all in all, if you total that one, you'll get that head loss total. So this is the type of a series flow. Pag hindi binigay yung head loss. So to find head loss, that is the formula usually. So what if pag series ng parallel naman siya? So find the total pipe system in the figure 0.86. So ang Q niya from point A is 0.86. Ito din yung lalabas na QB. 0.86. But at point 1, mahahati siya yung 0.86 mahahati siya sa tatlo. Pero ang lalabas niya, same pa din. Okay? So, the relationship between parallel is Q1, Q2 plus Q3 is equal to QT. That is the formula wherein yung head loss from point A to point B is equal. Head loss 1 equal to head loss 2 equal to head loss 3. So, yun yung pagkakaibahan ng series tsaka sa parallel. So, again, you'll use the formula 0.0826 FLQ squared over D raised to 5 since this is metric and this is head loss in terms of discharge. Okay. So, uunahin natin kukunin yung Q sub 1. From the formula, you play with the formula and get the Q raised to 1. So, if you substitute this one or you cross multiply this one and this is our denominator, makukuha mo yung Q sub 1. But since wala pang given na HL, hayaan muna natin yung HL na magiging variable. Ganon din yung gagawin nyo sa Q sub 2 and then sa Q sub 3. So, paano kayo kukuha ng given na to? Of course, given na din yan sa problem. You just have to memorize the formula. So, this is Q1, 0.0984 square root of HL1 Q2 is 0.02899 square root of HL2. Q sub 3 is 0.1678 square root of HL sub 3. Since meron na tayong Q1, Q2, and Q3, you can add this one since ang total niya is 0.86. Diba? I-add mo siya, HL1, HL2, and HL3. Makukuha mo yung HL. Since HL1, HL2, and HL3 is equal. Tama? So makukuha mo yan. Pag makukuha mo na yung HL, i-substitute mo yan dito. H. Okay. So substitute HL1, makukuha mo na yung Q1. Substitute HL2, makukuha mo yung HL2. Q2. Substitute HL3, makukuha mo na yung Q sub 3. Okay? So that is, if you total this one, makukuha mo yung 0.86. So that is how you solve a parallel type of problem. Parallel pipes flow. Anong oras na? Next is how we are going to solve a reservoir. Again, pag reservoir guys, ganito, V1 and V2 is 0, ang P1 0 or P sub A. So mga V nila ang P0. That is why yung ating mga energy head dito is magdedepende na lang sa Z. Z sub A, Z sub B, and Z sub C. Since makakancel na yung mga V sub 1 and P sub 1, which is used dun sa ating pressure head and kinetic head. So how do we solve this type of problem? So given, susulat natin yung given. And this is type of, given the following data for three reservoir. Reservoir B and C receives water, okay, from A. So reservoir B and C, reservoir B and reservoir C receives water from A. Okay? Or Q2, yung QB ha. Kapuyan. Q1 is equal to Q2 is equal to Q3. Same lang yan. And it says here that the head loss at point 3 is equal to 23 minus head loss 1. Okay. So to find first, makukuha na natin, ano ba yung hinahanap dito? The discharge at point 1, Q1, and Q2, and find the head losses of A, B, and C. So ano yung formula? So uunahin natin yung head loss at point 2. Since meron na siyang given na Q2 equal to 0.65. So HL2 is 0.0826 FLB squared over D raised to 5. So 0.0826 F at point 2. This is point 2 or point B, right? 0.169 L in meters, 450. And V, nasan yung V? Q squared. Sorry, mali yung formula. So this is Q2, which is 0.65. Diameter in meters, that is 0.6 raised to 5. Makukuha na natin yung HL2, which is equal to 3.413 meters. Next is we need to find the QA and QB. So QA, so from this formula, so galing lang dito na formula, we need to extract this formula para makuha yung Q. How do we extract that one? Cross multiply, di ba? Cross multiply mo yan, bababa yung nasa taas na yung HLA or HL1 times D raised to 5. Okay? This is 0.1. Kuya. And then since naka-square to, dapat naka-square root dito. So ang baba niyan ay ang denominator niya is 0.0826 f times L. Okay, so this is algebra only. We need to find the Q in terms of this formula. HL1 is wala. Times D, diameter at 0.1 in meters, 0.9 raised to 5. So constant 0.0826 times F at 0.1, that is 0.0208. And L pang 0.1, that is 1.5 meters. You'll get an equation 0.4782 square root of HL. Again, hahayaan muna natin yan maging variable. So, ang Q3 naman, again, same formula, but you'll use the values of 0.3. Hayaan mong HL3 since walang HL3. Ang diameter at 0.3 is 0.5 in meters. Ito, 0.0826 times F 0.0135 times the length of 0.3, that is 1,200. That is 0.1174 square root of HL. So let's use this formula to find the values of this one. So wait, I need the orange one. So since Q1 is equal to Q2 plus Q3 and meron tayong value ng Q2, di ba? So Q1 natin is 0.4782 square root of HL1. Q2 is 0.65. Ito. Q3 is 0.1174 square root of HL3. Gets? And since HL3 is equal to 23 minus HL1, substitute that. So 0.4782 square root of HL1 equal to 0.65 plus 0.1174 square root of, again, HL3 is 23 minus HL1. So masasolve na natin yung isang variable, which is HL1. Using calculator, you'll get HL1 or head loss 1, that is 5.66 meters. Okay? And also, since we are HL3 equal to 23 minus HL1, therefore 23 minus 5.66. So HL3 is equal to 17.34 meters. So since may value na tayo ng head loss 1 and head loss 3, we need to substitute that 1 sa ating formula kanina. So 0.47282 times HL1, which is 5.66. You'll get the Q1, which is 1.138 meter cube per second. And this is 0.1174 square root of HL3, that is 17.34, equal to 0.489 meter cube per second. Okay. So pag binigay itong F, you'll use the Darcy. What if binigay yung N? So you'll use the Hazen. Or you use the Chezi. Pag binigay yung C, you'll use the Chezi formula. So depende lang yan kung ano yung ibibigay na roughness coefficient sa formula na to. So solving head loss using Weisbach equation and friction factor using Moody diagram. So binabalik ko tong formula. Again, yung kanina, magdedepende yung value o yung formula mo if you're using F, you're using N and C, ito yung magiging formula. Dami siya, di ba? So, this formula can also be written as 0.0826 FLQ squared in SI. And ito yung derivation niya. Bakit naging 0.0826 siya sa SI in terms of Q? And head loss in terms of Q sa English, ito yung formula niya. 0.0252 FLQ squared over D raised to 5. Again, this is the original formula of Darcy-Weisbach in terms of F, A. So, I mean, Darcy-Weisbach in terms of velocity, and dinerive siya in terms of Q kasi laging given kasi yung Q. So, you can use this one SI in English, but in terms of Q, magdadalawa yung equation niya in terms of Q, head loss, in terms of Q, but this is in SI unit and this is in English unit. So, you need to memorize these formulas. Pwede namang ganito na lang yung i-memorize nyo, FLV squared over D raised times 2G, since ito naman yung naka-SI in English. But yung Q na yun, gagawin mo pa siyang velocity. Okay? So, alam nyo naman yung formula ng Q, that is area times velocity. So, yun lang yun. So, ganun lang yun yung process ng how to derive this one. Dinerive na lang siya para for the inconvenience sa mga estudyante. So, let's try to answer. So let's try to answer head losses in terms of Chesney Manning's formula and in terms of Hazen-Williams formula. Okay, again magdedepende yung formula ng head loss. Pag ang given is N, you'll use Chesney. Pag given yung C, you'll use William. Pag given is F, you'll use Darcy-Weisbach. Okay, let's write the given first. You have a diameter 15 centimeter. Again, gagawin natin tong gagawin na lang natin tong meters. And also discharge, length of the pipe, and the value of N. So, the formula for Chesney Manning in SI, since naka-SI to, again, this is in SI unit. So, may equivalent siya sa English unit. D raised to 16 over 3. Substitute. So that is the head loss one in terms of Chesney Manning. So let's try to solve using Hazen-Williams. So again, if you solve this one, given we have a diameter, same. This 0.020. The length of the pipe is 100. N is C na siya, naka-C na siya. Okay, iba din yung formula niya sa Hazen-Williams and SI unit. Okay? The formula is 10.67 LQ raised to 1.85 C 1.85 times D raised to 4.87. Again, this is SI unit. Ba't may 1? Overload. 1.1246 meters. Yun. So, that is how you solve Hazen Williams. Pagbigay is letter C. Chezzy Manning, pagbigay is N. So, yung formula in SI unit, SI unit. So, magkaiba din pag binigay yung mga values in English, then iba din yung formula niya. Okay, so next step is we need to solve the value of the friction. So let's focus on how to find friction. So hindi natin makukuha yung head loss pag wala tayong value ng F. So pag merong formula yung head loss, meron din yung formula yung value ng F. So how do we find the value of F? So ganito lang. So to find the value of friction, dalawa lang yon. So it's either pag laminar yung flow, we could have a formula. Pag laminar yung flow, sinulat ko ba? So to find the value of F, pag laminar lang yung flow, that is 64 over the Reynolds number. Pag turbulent yung flow, you need the Moody diagram. Okay, again, hindi natin makukuha yung head loss pag wala yung F. Meron tayong formula ng head loss. Pag binigay yung F, what if hindi binigay yung F? Ang value ng F magdedepende sa Reynolds number. So, kailangan nating alamin yung Reynolds number. Kaya, diniscuss natin siya before. So, pag nakuha natin yung Reynolds number na laminar siya, or that is, pag ang Reynolds number is less than 2,100, you'll use the formula 64 over the Reynolds number. Pag turbulent yung flow, which is yung Reynolds number is greater than 2,100, pag turbulent yung value ng flow, then you use Moody diagram. Okay, so ano ba yung Moody diagram? So, ang Moody diagram is a non-graph, a non-dimensional form that relates Darcy friction, Reynolds number, and relative roughness. So, Darcy equation can be used to calculate major head losses. So, the major friction factor determined in a Moody chart. So, meron tayong major head loss and minor head loss. So, sinabi ko na to last time, di ba? Ang pinaka-major head loss, reason ng head loss is friction. Minor lang yung mga design ng pipes or yung pagliko ng mga valves, okay? So, ano ba yung relative roughness? So, relative roughness where both the average height, the surface irregularities, and the pipe diameters are in millimeters. So, ang relative roughness, ito yung distance ng kalawang sa rough. Okay? O yung thickness ng kalawang na napaloob sa rough. This is caused by, so ito yung dahilan kung bakit mayroon tayong friction, yung mga irregularities sa loob ng pipes. So, the more na luma yung pipe, the more malaki yung friction. So, meron tayong mga values ng relative roughness. So, usually naka-epsilon to. So, millimeters or inches. So, depende sa type of material. So, ang gagawin mo lang is you need to get the value of the material in terms of the relative roughness. This one. So, ibibigay yan sa problem, yung mga table na ganito. So, ang titingnan mo lang kung ano yung type ng pipes doon sa problem. For example, pag cast iron and you're solving SI unit, then the value is 0.826. Okay? So, aalahanin mo lang on how to find the value of friction. Ito lang yung focus mo. So, let's try to solve an example. So, ito pala yung sinasabi kong Moody chart. So, how do we find the Moody chart? Kailangan lang ng Reynolds number. Ito yung nasa below ng chart, and the right side of the chart is the relative roughness. Hindi ko pala nasulat. relative roughness is equal to the epsilon over the diameter of the pipe. So ang E, magdedepende dito sa type ng material. Okay? And grain roughness, and D is the diameter of the pipe in millimeters. Of course, this is in millimeters, right? So ang value ng RR is unitless or relative roughness. So again, how do we find? So pag meron tayong Reynolds number and meron din tayong relative roughness, i-connect lang natin siya, makukuha na natin yung friction factor. That is the idea on how to find the friction factor. Again, kailangan mo lang yun ng value ng Reynolds number. Guguhit mo dyan. And then kailangan mo ng relative roughness. Pag nag-intersect yan, yun yung friction factor. Again, applicable lang to pag yung flow is turbulent. You cannot use Moody diagram pag pwede naman siyang i-use dito pag laminar yung flow since meron naman siya dito na value. But mas madali if ito na lang yung formula ang gagamitin mo pag laminar. Okay? So ginawan lang to para sa mga turbulent since walang formula yung turbulent flow. Sa laminar lang. But you can also use this for laminar. Pero mas mahirap nga lang. So let's try to solve this one. So there is an oil with a kinematic viscosity flows in a 15 centimeter pipe at a rate of 0.0220 cubic meter per second. What is the head loss per 100 millimeter of length? So given, ito yung given, we have the kinematic viscosity. So yun yung ating nasa properties. We also have diameter 15 centimeter, that is 0.15 meters, and discharge 0.020 cubic meter per second, and the length of pipe is 100. So let's use the formula for Darcy-Weisbach, itong 0.0826 FLQ squared over D raised to 5. Ang hinahanap kasi dito is head loss, but wala tayong value ng F or friction. So how do we find friction nga? Kailangan muna natin ng value ng Reynolds number. Ano nga yung formula ng Reynolds number? In terms of dynamic viscosity, ito yung dynamic viscosity. In terms of kinematic viscosity, ito yung formula. So we use this formula. As you can see, wala tayong value ng velocity. So kailangan natin ng velocity first. So this is velocity, this is diameter, this is kinematic viscosity which is given. So to find velocity, that is Q equal to A times V. So V is equal to Q over A. Q is 0.020. Area ng pipe is the diameter raised to pi D squared over 2. So ito ang radius na to ha, radius squared, pi r squared. So dinivide ko lang ng 2. Okay? So this is equal to 0.0, radius is 0.075. Okay, baka maguluhan kayo, bakit dinivide ko yan ng 2. Okay, magkukuroon na tayo ng velocity. Substitute the velocity, makukuha natin yung Reynolds number. So since the value of Reynolds number is below 2,100, then that is a laminar flow. Pag laminar flow, you'll use the formula 64 over the Reynolds number. 64 over the Reynolds number. You'll get the F. And pag meron na tayong F, meron na tayong head loss. Yun. So substitute the value of F from the formula, 0.0826 points, the value of F times 100 length times the discharge of 0.020 over the diameter of 0.15 raised to 5. So let's try an example pag ang nakuha natin is turbulent flow. Again, pag turbulent yung flow, you'll use the Moody diagram, Moody chart. Okay, let's write the given. Ito yung formula ng head loss. Okay, so to know the type of flow, you need the formula for the Reynolds number. Since ang given naman is dynamic viscosity, ito na yung magiging formula. So wala tayong V, so kailangan natin yung hahanapin yung V. This is the formula for V. Substitute the V, okay? This is the density of water, 1,000. Makukuha natin yung Reynolds number, 3.7, 1.67 times 10 raised to 5. Or that is uh, 317,000. 317,600. Okay? So this is the value of the Reynolds number. Again, this is greater than 2,100. Of course, very obvious. So, magiging turbulent. So, ano nga yun? Pag turbulent, you'll use the Moody diagram. So, ang unang kukunin muna natin is yung relative roughness. So, paano ba natin makukuha yung epsilon since meron tayong diameter na, di ba? From the given. So, gagawin lang natin tong millimeters. So, ang epsilon is hahanapan natin doon sa given. And since this is asphalted cast iron na pipe, balik tayo doon. Anong value ng epsilon? Okay? So you can see asphalted iron pipe that is 0.12 millimeters. So, ibibigay naman to pag meron tayong exam. Balik tayo. Okay, so 0.12 that is in millimeters. And then, i-divide mo siya sa diameters in millimeters, which is 200 millimeters. You'll get an relative roughness 0.006. Next is yung Reynolds number is, meron tayong Reynolds number, 317,000. So, ang kailangan mo lang is Reynolds number and relative roughness. Pag kinonect mo yan, makukuha mo yung value ng F. Balik tayo doon. So, 317 and 0.006. Okay. So, again, that is 0.006. So, ito yon, di ba? Yung RR doon. Find this one, this one, this one, this one, this one. And then, yung ating given doon is 317,000 something. Ang ating Reynolds number. So, as you can see, this is 1 million, 10 raised to 5. This is 500,000. Tama ba? Ay, wait. 10 raised to 5, that is 100,000. So, this is 100,000. This is 1 million. See? So, this is 500,000, right? So, this is 300,000. So, ang unit ng ating RA is 317,000. So, much more like dito siya. Okay? So, pag kinonect mo yan, this is 300,000. Pag kinonect mo yan, makukuha mo yung friction factor, 0.019 ata yun. So, ito yung RR, relative roughness, that is epsilon over the diameter, and ito yung Reynolds number. Balik tayo doon. So, ang nakuha natin na friction factor is 0.019. Yun, that is the friction factor. So, this one, substitute mo lang dito. Okay? So, makukuha mo na yung friction. Head loss. So, F is equal to 0.019. So, use this formula, you'll get the head loss. Okay? So, that's how you solve the friction. So, kailangan mo lang alamin yung type of flow. So, pag laminar, you'll use the formula RE over 64 over RE. Tama ba? 64 over RE. Yun. And pag turbulent, you'll use the Moody diagram. Sa Moody diagram, kailangan mo na ng relative roughness equal to the epsilon, magbabase sa type ng material over the diameter of the material. Kailangan mo din yun yung RE. So, pag na-intersect yun, yun yung ating value ng F. To find the head loss, substitute mo yun yung value ng F. Okay, itong problem na 'to is an example of all the lessons that we discussed. So, kino-combine lang siya. Okay, so a duct of water sample. So, merong duct of water which is SG 1.005 enters through a 500 millimeter diameter. So, and then meron din siyang 15, ito yung kanyang diagram. So, ang length ng first pipe is 3 meters or 3,000 millimeters ng length. Meron siyang 15 kilopascal na pressure at 0.1. Meron din siyang 500 diameter at 0.1. Again, the fluid flow is duct water. Okay? And at 0.2, meron siyang 750 na diameter. Meron siyang length ng pipe na 5 meters and meron siyang 8 kilopascal. If 500 liters of water pass through 500 liters of water per second. So same lang yan, Q1 and Q2 is equal. Find the surface elevation. So the formula here is we are considering friction since meron tayong uh, binigay na mga length. So head loss. So magiging ganito yung formula. Minus head loss. Okay, so ang hinahanap dito is the difference of the elevation from point 2 to point 1. Find the surface elevation where the total head loss of both pipe is considered. So we need to consider the head loss. So first wala tayong velocity 1 and velocity 2. So solve velocity 1 and velocity 2. That is Q1 over the area 1. To find the area 1, that is pi r squared. Next, since wala tayong head loss na binigay and then wala din tayong friction na binigay, kailangan muna natin dumaan sa paghanap ng friction. And since paghanap ng friction is kailangan muna natin alamin yung type ng flow, so kailangan muna natin isolve ito Reynolds number. So hindi pala nabigay dito yung viscosity which is 1.04 Newton meter squared per second. So this is the formula for Reynolds number at 0.1. Since dalawa yung pipe niya, pipe 1 and pipe 2, so dalawa din yung friction niya. Okay? So to find friction, kailangan mo na rin alamin yung type of flow. And since naalam natin yung type of flow niya is laminar, diretso na. The formula, and sa second pipe din, laminar din siya because that is less than 2,100, both of the pipes. So since less than 2,100, the formula for friction 1 is 64 over RE. Ganon din sa friction at 0.2. Okay? And since head loss 1 can be used by the formula 0.0826 FLQ squared over D5, makukuha natin yung head loss 1. Ganon din sa head loss 2. But you'll use the 0.078. And since this is a series pipe, we need to add the head loss. Okay? So, pag na-add natin yung head loss, ito na yung isa-substitute natin dito para makuha natin yung Z2 minus Z sub 1. So, you can see, sinubstitute ko lang yung mga values where head loss total is 0.13706. So, this is the value of HL sub 1 and this is the value of HL sub 2. So, you'll get the Z sub 2 minus Z sub 1. So, yun yung lahat ng lesson natin. So, medyo madami, no? So, all you need to do is to familiarize since ang quiz number 1 nyo naman is open notes. Of course, doon na lang kayo babawi doon na lang kayo mag-e-effort sa final exam ninyo, which is next week, Friday. Question? Go. Again, yung second quiz ninyo is on Monday, same type, online exam. And on Wednesday, you'll pass the problem set number 3. And on Friday, you'll pass, you'll be, your final exam will be on Friday. And your final exam will be two batches. So the odd numbers on the attendance will go the second or the second batch. In the first batch, yung mga even sa attendance. So on Friday, na yun, yung final exam nyo. Question. Next week, Friday. So, yun. So, you don't have any other question? Okay, so, since tulog pa kayo, then, see you next meeting on your quiz. Tapos na tayo sa fluid mechanics. So, thank you for listening, guys.
Thank you, sir.
Sir.
Sige po, sir.
Thank you po.
Thank you po, sir.